Good day, all. My name's Norma. I'm Brazilian and I'm a former NASA intern. Today, I interview Dr. David Sibeck. He's a space physicist studying the relationship between the Sun and Earth's magnetic field. He works in Maryland in the USA. He works at NASA. So, good day, Dr. Sibeck. How are you?
Good morning. I'm fine. I'm delighted to be here with you today. It's going to be an interesting discussion.
Well, I'll call you David from now on.
Yes,
Okay.
that's fine, Norma.
Um, I had a few questions for you about your career as a scientist. Can we
Okay.
get started?
Yeah, let's go.
Um, how did you choose science?
Well, I grew up at the beginning of the space age. And so the space was in the news, science was in the news. My parents strongly encouraged me to go into science, gave me all kinds of books about science when I was young. And I was fascinated by the world around me, full of questions, as many little boys are. Many little boys want to know about the stars, the sun, the ocean, the earth, rocks, minerals, plants, animals. And I was fascinated by all of those things, but most fascinated of all about the Earth's atmosphere. I really, really wanted to forecast the weather. I was surprised that there was so much variation. I was curious how it could be summer in the northern hemisphere and winter in the southern hemisphere, and that at a time like today when it's broiling hot here in Maryland, you in Brazil are wearing a coat because it's the middle of winter. And I
Yeah.
wanted to understand the weather. I read about it, and I decided that I was going to go to university and study how to forecast the weather. And it was possible to do that. I was growing up in Los Angeles, and the University of California in Los Angeles had a weather program. But when I got there, I found it was completely different than what I expected. Instead of learning how to forecast the weather, scientists there were developing big numerical models. It needs lots of mathematics and physics. And I might have gone into that subject, although I don't really enjoy computer programming, but for the fact that I received good grades in my first few classes. And because I received first good grades, I was called in to the professor's office after class. And I thought, oh no, have I made a mistake? Have I done something wrong? Why in the whole classroom is he asking me to stay behind and wants to talk to me? But it turned out he said, you got a good score, and there's a professor here who would like some student to work for them, and you will be paid if you help this professor. And the professor had some jobs making data plots, analyzing equations, looking at old data from satellites. And I really enjoyed that. And I found out that this professor did nothing at all related to weather forecasting. In fact, nothing related to the Earth's climate or weather at all. But what did she do? She was studying observations from space of
Mhm.
Earth's magnetic field and the particles around Earth. And after a couple years of working for her as an undergraduate, she said, would you like to stay here and go to graduate school and receive a doctoral degree in space physics, not in atmospheric sciences? So I had to think very, very carefully about that because my original plan had been to forecast the weather, and now
Mhm.
I was being given a chance to receive a paid because they would pay me to go to graduate school and work in something completely different. And I found that was a difficult decision to make. I like geography, I like the weather, but ultimately I did choose to go that route, and I'm very, very happy I did. So that's how I got into the field of space physics, connecting the sun to the earth.
And then somehow it started your NASA career.
Okay, so in our subject is a very small subject, and there are usually not many jobs available. And so towards the end of my career as a student, a scientist visited from the Johns Hopkins University, and he asked my professor if he had any students who were close to finishing because they were going to begin a new spacecraft project at Johns Hopkins University. And I remember being put in a quiet office with this visitor, and he leaned over and he said, "So would you like to come and work with us? Yes or no?" And I said, "Oh, this is another big decision. I'll have to think carefully about this and talk with my professor." "Give us your answer as soon as you can." And so I talked with my professor, and he said, "Oh, Johns Hopkins University is a very powerful research center with many good scientists. You will be making a good choice if you go there. And to be honest, you don't have too many choices where you can work, and they're going to start a new project. You should go there." So I spent a very happy 20 years working at Johns Hopkins University here in Maryland until my friend, my college friend from NASA, called and said, "We have a position at NASA. If you come over to NASA, you can work closely with more future missions. You can understand the system. You can be in charge of things over here." And at that point, I said a happy farewell to my colleagues at Johns Hopkins. We remained on very good terms. And I moved over to NASA and began learning about space mission management and began working on new missions, sometimes missions of my own. So it's been a very interesting career.
That's exciting.
Very exciting.
And the next question is, for you to become a scientist, both at Hopkins and at NASA, what preparation did you have?
I think in our subject, in space plasma physics, or some people call it heliophysics because the Greek word for the sun is helio, we have people from all different subjects because there is no person, no high school student goes to university and says, "I want to study the sun or space physics." You have to choose something else. And so some people in our field came from astronomy, some people came from geology, some people came from physics, some came from mathematics. There are a wide number of people, very different backgrounds. And that's one of the things that makes our subject so interesting. You meet people who have a completely different training and a completely different knowledge than you do. In my own case, as I said, I thought that I was going to learn weather forecasting and about clouds and about the oceans and the atmosphere. And I did. As an undergraduate at university, I took all the physics, the mathematics, and the atmospheric science courses that you need to forecast the weather. But then I was abruptly diverted into studying space physics. So my background was not perfect, but it contained enough of the information I needed to make a good start at studying space physics. One of the things I learned early on was perhaps that my theoretical background was not as strong as it could be. But as an observation person, I really enjoy that. I'm very excited to look at observations, to find patterns in the pictures, to find patterns in the data and analyze them. Our subject has room for people with all different backgrounds. In my case, I took the basics of physics and math, atmospheric sciences, but then I applied them to something completely different. And maybe that's a good thing because I brought my own fresh perspective to the field, my own ideas and my own background.
And David, for you to succeed in sciences in general, is it essential to be good at mathematics?
I think to succeed, you have to have the basics. The basics means going through trigonometry, geometry, calculus, and perhaps a little bit more. Uh, the basics help you understand what's going on, but on a day-to-day basis, I don't use that mathematics. Occasionally, I do. On a day-to-day basis, personally, I am looking at observations, pictures, images, graphs, trying to find patterns, looking at simulation output. It's a benefit to be very strong in mathematics, but it's not, you should have a basics there, but it's not absolutely essential to be the best at mathematics. There's room for everyone in our field.
But in the university, you have to be good at mathematics, don't you?
Yes, you have to take calculus and pass calculus. And there is a course called Mathematical Methods for Physicists. It's pretty
Mhm.
hard. It's a difficult course, and you have to at least give it a try. You have to think your way through it, and you have a book as a reference to use thereafter. Some people, mathematics is the basis for everything they do. Computer programmers, theorists in our field, they use it every single day. Other people, like me, occasionally make reference to mathematics.
Well, um, honestly speaking, we perhaps we can say that science is not for everyone. Well, what I mean is that there are people who choose humanities, there are people who will choose law, who will choose other careers different from, for example, space different from science. So, what is essential for a person who really wants to follow science?
Yeah, Norma, I think that the single most essential thing for a person who wants to follow science is curiosity,
Mhm.
to wonder how things work, to try to figure out how things work. As a child, I took many things apart, clocks and watches and golf balls. I was not able to put them back together again, but I learned a lot about how they worked from taking them apart. So the most crucial thing is is a curiosity about everything around you and a sense of wonder. And I think most children begin with that. If you look at children, they're always asking why, and that is something scientists continue to do. And they wonder, how is the world operating around them? And the world is a big place, so eventually you end up specializing and you become an expert on one aspect of the world around you. The most ability, curiosity, and ability to communicate, just like this broadcast that you're making, it's
Mhm.
essential for a scientist to learn how to communicate with others, to find the right language, to be able to describe what they're doing. Because something you discover, if you can't explain that to other people, it's not really a discovery because nobody learned anything. So, first step is curiosity. Second step is ability to tell a story, ability to tell other people why it's important and explain it to them.
It's excellent because, yes, you are right. Because if you have all the background and you do all your science, but you cannot communicate it to the public, so what is the
It
value?
had no meaning. Yeah, it had no
Yes,
impact.
yes, societal impacts.
Yeah. Yeah, and we have to
And
say it's something scientists have to learn to do. Many people go into science, they're introverts. They like to work quietly by themselves, but to have an impact, they need to learn to be extroverts, to talk to others, to tell what they're doing.
that is why there are so many scientific events around the world.
Yes, yes, it's true.
And David, what projects did you work on and what did you learn?
So, as I mentioned, my very first job after leaving university was to work at the Johns Hopkins University.
Mhm.
And that was a good choice. I didn't have many choices. That was a good choice. It was the best choice because they had a brand new mission. And in this mission, the United States had built one spacecraft, the United Kingdom had built a second spacecraft, and
Mhm.
Germany had built a third spacecraft. They were all launched at the same time, and they cooperated with each other to
Mhm.
see what observations they could make in conjunction and understand how the sun interacts with the Earth's magnetic field. So that was a wonderful experience. We went to meetings in England with the
Mhm.
English and Germany with the Germans. We presented our results. It was a very lively, it's very exciting to be involved in working with a new mission, looking at Earth's magnetic field, looking at the particles around Earth. Uh, Subsequently, I worked with a variety of NASA spacecraft. One of the most interesting projects I worked on was with the Russians and with Eastern Europeans. In the late 1990s, Russia launched the Interball program. This was a set of spacecraft with instruments from many countries in Eastern Europe. And because I was interested in Eastern Europe, I applied to work with them. I received funding from NASA to work with them. I had a very exciting time visiting Moscow at a time of great change in the late 1990s, early 2000s, working with really good scientists in Eastern Europe, again, to study the relationship of the sun and the Earth's magnetic field.
Wow, that sounds very exciting.
It was fun. It was good.
And David, what are the good and bad points about being a scientist?
I think that I've just mentioned one of the best things about being a scientist in our field. You know, space is very, very large, and we
Mm-hmm.
have very, very few spacecraft. And so, to get a good picture of what's going on, we need to cooperate with each other. One person's measuring over here, another person's measuring over there. If you want to understand the picture, you need both spacecraft in both places. You need observations on the ground at high latitudes in Greenland. You need observations at low latitudes in Brazil. So, to understand what's going on, you have to work with a lot of people. And for a person who is interested about the world, about other countries, about joint projects, our subject is wonderful. I have worked very closely with great scientists in Brazil at INPE in São José dos Campos. I have worked closely with scientists in Peru, in Mexico, all over Europe, in Asia. And I really get an excitement out of doing joint projects with people around the world. It's a great pleasure. Another excitement, probably the biggest excitement you can get, is when you make a discovery and you think, I'm the only person in the world that knows this. Well, you are until you explain it to other people. And then it's a great pleasure to tell other people what your new idea is. And you have to expect they may criticize. And so you'll have discussions and arguments. And it's very interesting to go back and forth getting the idea right via discussion. The third thing that I love about being a scientist is training early career people. I really, really like to make opportunities for young scientists to get their own position, find their own subject, make their own discovery. It's a beautiful thing to see when somebody's confidence grows to the realize that they can do the job just like everyone else, and they can succeed, and they can make a discovery, and then to see them go on to become professors at universities. It's a very good feeling.
Yes.
Yeah.
And so you have projects with scientists from all around the world.
I do. We work with scientists in almost every country. They come and visit us at NASA. We go to visit them. We exchange students. We think about research projects together, and we plan future programs. It's wonderful. It's good.
Yes. And which was your greatest achievement to date as a scientist?
One way that we measure achievement in sciences is by how many times people reference your paper or quote your work. If people think your work is important, then they mention it when they write their own science papers. And my paper that has the most references or has been quoted the most is a paper that defines the shape of the magnetic bubble that surrounds the Earth and protects us from the sun. And to write that paper, I contacted everyone I knew who had ever observed the edges of that magnetic bubble, assembled a big list of spacecraft observations, and then I fit a model to define this enormous bubble that surrounds the Earth. It has a sharp outer edge, and all the solar wind radiation is deflected around it. And so many people make use of that because it tells them when and where to look for that bubble in their own spacecraft mission. It tells us something about the nature of the sun's interaction with the Earth's magnetic field. So that's probably been my biggest discovery or biggest service to the community. And by the way, it was done as completely apart from my work. That was not what I was being paid to do. But I suddenly realized I could do this and it would help a lot of people. And so I did it in my part-time. And so sometimes you are told, work in this direction, do this thing, and you end up doing something completely different. Every day as a scientist is a different day. Every day you look at something new and different and go off in a different direction. The results are unpredictable, but if you're motivated, if you're enthusiastic, you're sure to get good results.
So you worked on your free time and it was a big success.
And it was my biggest success. The best thing I ever did was done on my free time, not as part of my job.
Wow.
But that's okay. That's how science is. You get an idea, you pursue it.
Yes. And what do you think is unique about science as a career?
I think science as a career is exciting. I think it's open to everyone. Everyone can become a scientist to one degree or more. And the more you look and learn, the better you will do. I like science because it helps me understand everything around me, and it encourages me to try to understand what the weather will be like, what the soil is like in my garden, which plants can I grow, uh, how paintings are made, how you get different colors. It just gives me a feeling that I understand the world around me and that I'm solving mysteries. And so every single day is an exciting and an interesting day if you maintain a curiosity about the world around you.
Yes. And what is your advice for young people who want to become a scientist?
So I have several advices for young people. The first is, as you have mentioned before, see if you like and can enjoy physics and math classes. But it's not required to be the best physics student or the best chemistry student or the best mathematics student. You don't have to be the best to succeed. What you really have to do is be persistent. You never give up. You keep trying. You look and you look again. In the end, it's the persistent people that succeed. The brilliant may succeed, may not, but it's the ones who keep trying, who find a question, find something they want to answer, and look and look and look and think about it. That's how real science progress is made. The other suggestion I have is to contact scientists in your community, at a university, at a research center, and ask them if they have summertime experiences. It's very interesting to see how scientists work. I know, for example, that at INPE, the National Institute for Space Research in Brazil, they have opportunities for young students to come and work with them. Imagine taking that chance to see how scientists work, to learn what it's like to be a scientist. Then you'll know if you enjoy that life. You will know if solving mysteries, solving puzzles, solving questions is something you like to do. You'll find out if you like technical work. By the way, there are so many kinds of scientists. There are scientists who build instruments. There are scientists who write computer programs. There are scientists who look at data. There are scientists who simply think, and write equations on pieces of paper. There's room for a lot of people to become scientists with a lot of different skills. And so we all have to sort it out. Which kind of scientist am I? What do I like doing?
Yes, because there are different scientific fields, so
Yeah,
different skills, different personalities.
very different, very different. And so it takes some experiment to see what is it I like to do, which kind of scientist am I? Many choices.
Yes. And how do you think science could be more popular in society?
Well, one of my disappointments is that although science is all around us, medical science, science of aviation, airplanes, the science of designing cars, the science of building roads, the science of agriculture, the science of predicting the weather, the news media don't present that as exciting as it could be. I wish there were more programs on television explaining how the world works, explaining how we fit into the world to help us see, and telling us what we know and what we don't know, and encouraging that sense of wonder, excitement about the world around us, and the thrill of making discoveries that benefit people. So I wish there were more programs on television that told us about famous scientists like Madame Curie
Mhm.
or Einstein or other people who did wonderful things. We should all know their stories,
Yeah.
the difficulties that they faced, and the successes that they had, because their work has changed all of our lives. It's
Mhm.
they're not remote. When you see what they've done, everything they did has bettered our lives. We should know more about them.
We are getting close to the end of this interview, David. So thank you very much for being here with our audience today. I'm sure that the insights and the knowledge that you shared today helped many of young people to decide for their careers and grown-ups to think about science as something very essential for societal development. So thank you very much for being here today, David.
It's been a pleasure, Norma. Thank you for the opportunity to talk to everyone. Bye bye.
Bye bye.